All right, so we are going to make sense of the notes that we had over Thanksgiving. So they have two lines for you. One is x equals y squared, so you can see that the parabola goes along the x-axis instead of the y-axis. So it's kind of like, if we would have graphed it, we would have thought of it like this. It's like a parabola on its side, right? And then it has the line x equals 9. That's this line right here. That's what cuts off that parabola. You guys see that? Okay. So they're saying that they're going to take squares and they're going to be perpendicular to the x-axis. So you can see there's a 90-degree angle right there. And when it says perpendicular to the x-axis, that means that everything needs to be in terms of x. All the things you do have to be in terms of x. So your curve has to be in terms of x. Your bounds are going to need x values, dx, all of that stuff. That's what perpendicular to the x-axis means. So just be careful to watch for that now that we've been kind of switching back and forth between x's and y's. So we have this square right here, but if we were able to like draw all the squares, we're going to have another square like right next to it. And then we're going to have another square right next to that. And then we're going to have another square right next to that. And then we're going to have another square right next to that. Because it's getting closer. I'm drawing it 3D like. Don't be sassy. Rude. All right, so.
It's smaller as it gets farther away.
And it's going to. Yeah. You guys are so sassy. All right, so right now one of our curves is written in terms of y instead of in terms of x, so we do need to change that. So what should we do?
Root x. Well, plus or minus.
Yeah, so we need to square root each side, and since we are the ones doing the square root, then we need a plus or minus. Okay, so in the notes I talked about figuring out what S is. And S is like the slice. And you have to do top minus bottom, or you have to do right minus left. Now, since this is in terms of x, we're going to do top minus bottom. Okay, so this is our top curve. This is our bottom curve. So if we do top minus bottom, what do we have?
You have square root x minus negative square root x.
You have root x, that's your square root x curve right here, if you guys can see that. And then the bottom curve is your negative square root x curve down here. Does that make sense? So top minus bottom would be square root x minus negative square root x. So you really have root x plus root x, which is 2 square root x. So that's what our S is going to be for the entire sheet, because we're working with the same thing over and over and over again. Okay,
If it were
so
perpendicular to the y-axis, would it be going down like this?
if it was perpendicular to the y-axis, they would have been this way. And then we would have had right minus left. We would have had right minus left, so it would have been 9 minus y squared. Does that make sense? Okay. All right, so we have 2 square root x. Our bounds are from 0 to 9. How did I know that?
Because it begins at 0.
Yeah, begins at 0, ends at 9. Okay, that's where it was cut. We have to say one side length of the square, which I'm going to go ahead and label it. This right here would be S, right? That's top minus bottom. And then since it's a square, this is also going to be S. So how do I find the area of the square?
S squared.
S squared. So we're going to write 2 square root x squared dx.
Well, that wasn't so hard.
Okay. And the reason that this is adding up all of those squares is because we have to think back to that original limit definition of an integral. Do you guys remember that? The limit definition of an integral was taking like little areas and adding a bunch of them up. And so this is saying we're taking a square and we're adding a bunch of them up. Infinitely many squares. Okay, so let's go ahead and type this in our calculators and see what we get. Miss Rice, I'm not typing it because you're my calculator. No, I'm not. Do it yourself. Okay, and then what did we get?
160 squares. That would be that.
Okay, and that would be a volume, right? Because we have all these squares and they're making a 3D
I really
shape.
liked how in the video, all of them were pretty close to each other, except for the rectangle one.
Yeah.
4 times the highest of the high one. It was like 4,
Yeah.
8, pi.
Yeah. All right, so here, again, we're going to have our top minus bottom. So this is a rectangle with a height of 2. So the length of the rectangle is going to be that same S that we already found. And then the height of the rectangle is 2. So we're going to say the integral from 0 to 9. And then what are we going to do?
2 parentheses square root x. Or 2 square root x.
So this is our height
Times the length.
times the length, and the length happens to be the length of the slice. Okay, and then we've got our dx. Anyone forget their dx? No? Oh, fine.
You just want to kill some animals.
Sure do.
So why was the last one squared but this one isn't?
Because the last one, the s, since it was a square, it was this times, yeah.
It is squared, but it's 2 times. The 2 is one of the lengths.
Yeah.
Before we could just multiply
Yeah,
the same.
'cause it was the same.
Instead we had to multiply by
Mhm.
okay. 2 is
So simplify that.
If the height is dependent on
Yeah, you can say 72.
the side length, then there's squaring going on.
Mm-hmm.
I was going to say I can simplify.
Okay. A semicircle.
Wait,
All
should
right.
we label this with units cubed or?
It would be units cubed. Yep. We can go ahead and do that if you want. Okay. The semicircle had the weird formula. Do you guys remember?
1/8 pi.
Okay. Does anyone...
It does make sense if you think.
Yeah, let's talk again about where it came from just so that we...
1/2 times 1/2 squared.
Isn't it because the height is squared and the height is 1/2?
Yeah,
that
well,
becomes
because
one.
So
the height, or
this
not the height,
this
not
is
the
the
height,
S, right? But this is R. So the formula would be 1/2 pi R squared, right? Circle, but 1/2 of the circle. But if we have the R, we actually have, wait, S equals 2R. 2R, R equals S. How did I do that?
It was
1/2 S.
Oh, yeah, okay. 1/2 pi, 1/2 S squared. And so then you've got 1/2 pi times 1/4 S squared. That's where we got that from. Okay. So that's a good one to memorize just because I think that 1/8, if you're not thinking about where it came from, it's easy to make a mistake there. Okay. So we have from 0 to 9, and then what should we write?
1/8 pi
2 root x.
squared d.
Okay.
What is the point of finding these volumes?
I mean, this same question is what's the point of doing any of it?
Well, yeah, but like for derivatives, we're finding the slope.
Well, this is kind of like, okay, so when you were in middle school, they'd say find the volume of a Pringles can or find the volume of a cereal box or find the volume of whatever. Now we can start having more complicated shapes and we can still find the volume because we have other methods of doing so.
We're finding the volume really weird. Like when we do a rectangle with a height of a building, count the spaces. It's like we keep getting super crazy.
But the purpose is like if at this point if you had like a funky shape now and you needed to find the volume of it, you could like break it down into composite shapes, and now you could be like, okay, if it's a prism, I can still find the volume of that. I learned that in middle school. But now if it has like a curve that goes in and out, if I can find an equation that models that curve, now all of a sudden I can have a rotation with that if I need to have a rotation to make it match that shape, or if it doesn't match that shape with a rotation, if it's like flat on one side, I could use a square to find it. Now at this point they're saying if something's not uniform, we could still find its volume. We could just manipulate it to like match what we know how to do now. It's just another tool for finding a volume. Yeah. All right, so at this point, we've already found the integral of this part, right? That was the 162, right? So now we could just say 162/8 pi. We can see if that simplifies, but if it doesn't, then we can just leave it.
A little bit.
It doesn't.
I think it's 81/4.
Yeah.
Yeah. Yes. That's the definition of simplifies a little bit. Yep.
All right, let's go ahead and flip.
That one's.
Now this one's a quarter circle, which you think would use a smaller fraction than the semicircle, because a semicircle is half a circle and a quarter circle is a fourth of a circle, but look at your radius. It's the same as S. Okay, so since the radius is exactly the same as S, so there's our S, which also happens to match our radius, then we would say that the formula for finding the area of a quarter circle would be, it'd be pi r squared times 1/4, that's a quarter circle. And since r and s are exactly the same in this case, then we're going to go ahead and use 1/4 pi s squared. So our quarter circle is going to give us a bigger volume than our semicircle did, because our semicircle has a much smaller radius. You guys see that? Okay.
So, if it's a semicircle, wouldn't there be two radiuses on it?
Yes.
Yeah.
There's a full diameter there. Okay, so we've got from 0 to 9, 1/4 pi 2 root x squared dx. And then just like I did before, we can say 162/4 pi.
162 or 81 over 2.
Well, 81 pi.
81/2 pi, because we just took it. We went from 1/8 to 1/4, which means that we multiplied it by 2.
Wait.
Yeah, we just doubled the volume.
Isn't it 81/4?
That was the previous problem.
Oh yeah, this is 1/8. How do you get from the 1/4 pi r squared to the 1/4 pi s squared?
Because the r and the s are the same. That's the radius of the circle.
Yeah, that's what I'm doing.
Because like this is the center of the circle right here.
That's the end. On the other side.
That's the edge of the curve, so this is the radius.
So R equals S, so you can just replace it.
All right, anyone have their notes for equilateral triangle? √3/4 s squared. Okay, so we've got 0 to 9. I'm going to go ahead and put the √3/4 in the front. I'm only doing that because we've been doing that the last couple times, where we've just kind of thought of the coefficient as being in the front, so we can see that this is the same thing.
It's a lot nicer.
Yeah. So now we can say we've got √3/4 multiplied by what? What was the integral in the beginning?
162.
Times 162. And we've already done the math, so we already know that 162/4.
81/3/2.
Is it illegal to write it √381/2?
No, but people will just be like, oh, that's kind of weird. Okay.
Was the
Like
point
this
of writing plus or minus square root x just
You can get
to
arrested
note
for
it,
that.
like it doesn't actually affect what we're doing?
It did.
I mean, FRQ.
It did, because we had to have top minus bottom. If you had just said y equals square root x, you would have gotten stuck in the beginning, because you would have been like, am I doing square root x minus 0? How am I doing top minus bottom here? So when you do the plus minus, you can see that you have a positive square root and a negative square root, and that's where your top minus bottom comes from. Does that make sense? Okay. All right. A triangle with a height that's equal to 1/4 the length of the base. So to do this, we have to think about area of a triangle, which is
1/2 base times height.
1/2 base times height.
1/2 s
So-
times 1/4 s.
Yeah, so the base is definitely S, and it says the height is 1/4 the length of the base. So we're going to have 1/2 times the base times 1/4 the length of the base.
So we get 1/8 S squared.
Okay, so we have 1/8 S squared. Okay. 0 to 9.
Anything. Don't kill anything.
Okay. So this is really similar to one of the answers we already found.
162 over 8, it's 81 over 4.
Okay. 162 over 8.
Wish that canceled. Looks like it should.
It feels like it should with the 8 and the 4, but no.
Well, it's good. Both square numbers. We could do 9 squared over 2 squared. But happy. Or
9 over 2 is squared.
Yeah, 9.5 squared.
4.5 squared.
4.5. Yeah.
All right.
I'm writing it as that. You can't stop.
All right. A trapezoid. What's the area of a trapezoid?
Half base 1
Plus base 2
times side.
Okay. A trapezoid with the lower base in line with the xy plane and an upper base that is 1/2 the length of the lower base. So if the lower base is S, then what's the upper base? 1/2 S. Okay? And a height that is equal to 1/4 the length of the lower base.
1/4 S.
1/4 S. Okay, so we have 1/2 S plus 1.5 S times 1/4 S. So we've got 1/8 S times, so I just took these on the outsides and I multiplied them. So 1/8 S times
S plus 1/2 S squared.
It's S cubed.
What do we have here? 3/2 S. Okay. So we have 3/16
S squared.
S squared. Okay. So we've got 3/16 0 to 9. So we've got 3 times 162 over 16. Ah!
Good call, Grace.
Plus C.
I hate you.
There's no plus C in this.
Yeah, I know.
Yeah, I know, but I don't like to joke when it comes to this.
Don't like to joke about.
I like it when my math is accurate.
I understand this, so I'm taking it seriously.
Yes. Fair enough. All right. What do we think?
Why did you write? Oh, that's times 162. I thought that was 16 squared, and I'm like,
For a second, I thought you were 3,162. I was like, where did we get that? That's
why
like
is
a little
that
big.
with us? 3.1.
I didn't think she was excited.
Yeah.
It's crazy what happens when you follow the context of the problem instead of copying down what I wrote. Makes
No,
a lot
I
more
wrote-
sense, right, Tristan?
I wrote
Right,
it down
Tristan?
3 times 162, but I looked up and it looked like you had 3,162.
All right. So I have an assignment for you now to practice. So the one thing you really have to watch out for before you even get started is see what it says it's perpendicular to, because that will affect the entire problem. So is it perpendicular to the x-axis? Do all x's. If it's perpendicular to the y-axis, all y's. Okay? Make sense? What else is super important to know from the beginning?
What is on? Like the range?
Yeah, your bounds. You need to know what your S is. So you have to be able to figure out your top minus bottom. If it was perpendicular to the y-axis, what would you be doing instead?
Right minus left.
Right minus left. Okay, top minus bottom or right minus left. And then on your cheat sheet, I'm going to make you guys a list of things to put on there, but you're going to need to have formulas. And I think this has more formulas than even your notes had, right? So just make sure.
We didn't have quarter circles.
Yeah, we didn't have a quarter circle on our notes. We didn't have a trapezoid on our notes. So it might be good for you to keep this sheet and then use this when you do your cheat sheet.
Paste it on the cheat sheet.
Minimize it? Like trace it smaller?
So like skin the ends and shrink that.
You can use a computer. You've always been welcome to use a computer.
Would you shrink the entire vein?
I'm gonna add
That you can't really see.